Magic experiments with entangled particles continue as multiplex memory-provided teleportation of quantum information for a whopping 1 kilometer distance. Quantum teleportation is a method that allows the transfer of quantum information between two distant objects due to the phenomenon of entanglement. The unique feature of this process is that information does not move but is destroyed at one point and arises at another point. Using a new approach, Catalan scientists have achieved quantum teleportation from a photon to a solid-state qubit over a distance of 1 kilometer. The quantum world is not that far from ours, although its laws often seem strange and counterintuitive to us. However, the important news from quantum physics comes literally every day, and sometimes the work of physicists in our eyes turns from science into magic and becomes overgrown with myths. A striking example is quantum teleportation, around which so much misunderstanding has accumulated that even science journalists usually cannot describe such experiments correctly. Theoretically, quantum teleportation was described in the early 90s. Since then, several groups of scientists have experimentally confirmed the possibility of realizing this phenomenon, although exactly how to apply it in practice remains an open question. Obviously, such an infrastructure must be compatible with existing telecommunications. In addition, the quantum teleportation protocol requires the application of an active preemption operation to the teleported qubit, which ensures high speed and reliability of information transfer. And finally, quantum memory must operate in multiplex mode to maximize the speed of teleportation over long distances. So far, all three conditions in one system have not been demonstrated. Scientists from Catalan Institute for Advanced Studies, ICREA, reported the achievement of quantum teleportation over a long distance of information from one photon to another, which was in a multiplex quantum memory. This method included the use of an active look-ahead scheme, which together with the multimodality of memory allows you to push the data rate to the limit. The proposed architecture is compatible with modern telecommunication channels, writes Science Daily. The researchers built an experimental setup consisting of two nodes, Alice and Bob, separated by a coil of optical fiber 1 kilometer long. In Alice, the scientists used a special crystal to create two entangled photons, a single and an idler, compatible with telecommunication infrastructure. The first photon was stored in a multiplex solid-state memory, and a telecommunications photon was sent to Bob. There was another crystal with a third photon in which the quantum bit was encoded. As soon as the second photon arrived, it entered into an interaction with the third in the so-called Bell state. Since the first and second photons were initially entangled, information was transmitted from the third photon to the first one, which remained with Alice a kilometer from Bob. The team was not going to stop there and plans to increase the distance of quantum teleportation while maintaining high efficiency and speed. Their second goal is to study and possibly the use of the method to transfer information between different types of quantum nodes. At the beginning of the 21st century, the Japanese physicist Masahiro Hotta put forward the idea of quantum energy teleportation and even developed a theoretical justification for this. And earlier this year, his US colleague announced the first successful teleportation of energy using a conventional quantum computer. This is an article on SoulAsk. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.